Hello and welcome to Maths with Jacob. This lesson will focus on chance, part 3. In the last few videos, we have seen a number of examples where the outcomes have an equal chance of occurring. There are examples of many outcomes in the real world where the chances of success are not equal. Example 1. Consider the following container and the marbles contained in it. Now if we look carefully, we see 4 reds, 2 blues and 1 green marble. So you can see that the numbers are not equal. So following on from the previous video, we have the probability of picking a red. If we closed our eyes and put our hands in the box, the probability of picking a red will be 4 because there are 4 reds, over 7 because there are 7 marbles altogether. So the probability is 4 over 7. The probability of picking a blue is 2 over 7 for obvious reasons, and the probability of picking a green is 1 over 7 for obvious reasons. So you can see that the probabilities, or the chance of picking the different colours, are not the same. The red has more chance of being picked out. Example 2. Now this is a spinner. So for example, pretend you put your finger on this arrow and you started spinning it. Notice that there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 sectors. That is, there are 8 equal parts that divide the circle. So you have 2 of them here. Can you see here? 2 of them are coloured red. 2 of them are coloured yellow. 3 of them are coloured purple. 1 of them is coloured blue. So they're different because there are more purples, if you like, than any other colour. There's less blue than any other colour. So can you see from that that when you spin the arrow, there's less chance of landing on a blue, for example, and there's more chance of landing on a purple. So the probability of landing on a blue is 1 over 8 because there's 1 blue and 8 possible areas. The probability of landing on a red is 2 over 8 for obvious reasons. The probability of landing on a yellow is the same, and the probability of landing on a purple is 3 over 8. Example 3. In a class of 30 students, 12 of them play basketball, 10 play hockey, and 8 play tennis. If a student was picked at random, what is the probability that the student plays basketball? Now it's very important to understand what it means when you say the student was picked at random. All that means is pretend that the 30 names were put in a box and the box was held up high and a person put their hand in and picked a name, one name. They have no idea which name is coming out of the box. That's what it means when you say picking at random. You don't know who is being picked. It's all by chance. So the probability of picking a name of a student that plays basketball is 12 over 30 because 12 of them play basketball. The probability of picking a student that plays hockey is 10 over 30 because 10 of them play hockey. And the probability of picking a student who plays tennis is 8 over 30 because 8 of them play tennis. So you can see the probabilities are not equal. The next one. This is a table which shows how students in a class get to school. So you've got walking, car, bus, cycle, train, taxi. So you've got 6 different ways of getting to school. A student is picked at random. Now we know what random means now, by chance. What is the probability that this student catches a train? So the probability that the student who is picked catches a train is 1 over 30, because there's only 1 student in the class who catches a train. The probability that the student who is picked walks is 8 over 30, because 8 students walk. Example 5. Now this is a very, very interesting example. Here I want you to pretend that you have 2 dice. So there are a lot of games that you play where you throw 2 dice. So let's imagine you throw the 2 dice and they land on the table. Okay? The idea is that you want to add up both of the dots and see what the total is. So that's the idea of this exercise. In other words, when you throw one of the die, D-I-E is singular, you can have from 1 to 6 on one of them, you can have from 1 to 6 on the other. That's why I've got those die here on each of the axes. So for example, if one of them showed a 1 and the other one showed a 1, that total is 2. That's what that means. If one of them showed a 1 and the other one showed a 2, that total is 3. If one of them showed a 1 and the other one showed a 3, that total is 4. Let's do one more and then we'll move on to the exercises. Let's look at this section here where the 9 is. What does that mean? It means one of them showed a 5 and the other one showed a 4, and that total is 9. So they're all the answers. They're all the possible answers. There are 36 of them when you throw 2 dice and you add up the faces on top. So the results in the table to the left shows the number of faces when 2 dice are tossed. That is the sum of the faces. Sum means you add them up. The sum of the faces. We can see that the probabilities of many sums are not equal. The following few examples will show this fact. The probability that a 2 will show up is 1 over 36 because there is only one chance of throwing a 2 if both of them are a 1. If you have 1 on each die, that is the only way you can throw a 2. There's 1 out of 36, and that's why it's 1 over 36. The probability that you can throw a total of 3, there are 2 3s, 1 there and 1 there, and that's why it's 2 over 36. The probability of throwing a 4, 1, 2, 3. There are 3 4s, so it's 3 over 36. The probability of throwing a 5, 1, 2, 3, 4. So that probability is 4 over 36. The probability of throwing a total of 6, 1, 2, 3, 4, 5. That's 5 over 36. And the probability that the sum is 7, 1, 2, 3, 4, 5, 6. Which is 6 over 36. So you can see that those probabilities are definitely not equal. So they're examples which show you that there are events in life where the probabilities are not equal.